friends, welcome back. Today we are talking about relations and functions, and this is so exciting because this is really starting to get into the crux of algebra. You're going to dive deep into this in Algebra 1 and Algebra 2. We're going to talk about all kinds of functions. However, for pre-algebra, we're going to start with linear functions, aka lines. But first, before we even start with linear functions, we have to talk about what a relation and a function is. So grab your notebook or your piece of paper, anything that you use to take notes. I'm going to have you write down a couple of things that I want you to take away from this lesson that are the most important parts. Here's our first one, a relation. All this is a group of ordered pairs. Write that down. I'm sorry, my highlighter kind of messed that up. It says relation. Relation is just a group of ordered pairs. Now, this can be demonstrated in several different ways, okay? And I'm going to go through each of these ways on my notes here. However, you don't have to write them down. If you want, you can, but that way you have a general idea. The first is just a group of ordered pairs. We write them down exactly like this. That's great. Another method is a table, and a table is going to look like this. Now, as we go along, we'll come back to this vocab over here, but a table just looks like an XY chart. In fact, sometimes it is called an XY chart. I can't talk today. Mapping, this is another example. So if you take a look at this, you have bubbles, you have your X, you got your Y, you map this out. So what this would look like is, okay, we have -2 and it goes to -3. Then we have -2, which goes to -1. I don't know why I messed that up there. And then we have like 4, 0, and 7, 7, 4. Now, the last method is graphing. We can look at a graph and find our group of ordered pairs here. And so these 4 different methods are ways of demonstrating relations, okay? Now, what I want you to do is, like I said, write down relation, a group of ordered pairs. Your other 2 big things that if you take away nothing else from this lesson, I want you to learn your domain is the same as your X, which is the same as your input. All those mean the same thing. Range, Y, output, same thing. Okay, so if you need to, pause the video, write those down. Okay, so now that we've got what a relation is out of the way, we're going to talk about functions. Okay, so for a function, some relations can be functions. Not all of relations are functions, just some. How can we tell if a relation is function? X cannot repeat. That's the easiest way to say that. An X cannot repeat. The technical answer here is for every input, there's exactly one output. Now remember, input means X, which means domain. Output means range, which means Y. So let's talk about this in non-math terms. I happen to love reading books. So we are going to talk about this thing right here. Now, here is a list of my inputs, aka my X's, and my outputs, which are my Y's. Here is my machine, and that's all a function is just a machine. I'm going to take this and I am going to put into my machine an input, and I'm going to get out an output. I'm going to put in To Kill a Mockingbird. I picked this because if you haven't read it yet, there's a little girl, I think she's like 5 or 6, I can't remember, but she's like super spicy and like not girly like. Anyway, her name's Scout, and that's what I named my dog after her. So I had to throw that in there. To Kill a Mockingbird was written by Harper Lee. Okay, cool. Now we've got Harry Potter and the Sorcerer's Stone and Harry Potter and the Deathly Hallows. Those were both written by J.K. Rowling. All right, cool. A Deadly Education. If you haven't read this, it's like Harry Potter, but with a lot more blood. It's great. A lot of murder. It's fun. Naomi Novik. It's a young adult book, so don't think that it's too terrible. The Calculating Stars. This is a great one. This was written by Mary Robinette Kowal. Okay, so what I've done is I put an input, or an aka an X, or my domain. I input this into my author machine. I got out the actual author. This machine is working great. Notice that this part, so let's say that I take this, and bear with me here. Now let's say that I take this and I put in a Deadly Education, and I get out Naomi Novik, right? And I put in a Deadly Education again, and I get out Harper Lee. That machine is broken because we cannot have 2 authors that write the same book. Thinking specifically a single author book, right? So we can't have 2 authors that write the exact same book. So if we have that happen, that is not a function because our X is repeating. We're getting a different output every time. So if you have anything that you take away from today, we know x equals domain equals our input, our y is our range, which is our output, and x cannot repeat. So for a function, x cannot repeat. I can't have two different authors for a one author book. Now let's talk about this in graphing form. In graphing form, it looks like this. Another way to determine a graph, a function, is if you graph it. It must pass that vertical line test. Now let's talk about that vertical line test. Okay, I had to pause it for a second so that I could get my vertical line. So this is my vertical line. You'll see I just folded a card in half and I've identified my vertical line as this pink line. So it must pass the vertical line test. So let's take a look at this first function here. This means it can only go through the function at one point. And if you'll see here, I go through 1 point, that's fine. But if I slide this over, you'll see that I go through 2 points. And those points are, let me find my marker here. We go over -2 up 2. So that's -2, 2. And we go down -2, -1. So you'll see -2, 2, -2, 1. My x repeats, right? I get two different outputs. That is why it doesn't pass the vertical line test. It does over here, it does over here, but because it doesn't here, this guy, not a function. Now let's look at this one. Over here, if I slide my vertical line across this guy right here, you'll see that it never crosses my vertical line more than one time. It's always one. So this, yes, this is a function. Is this guy a function? No, let's write that down. Whoops, I don't know how to write. There we go. No, it's not a function. Is this guy right here a function? No, because you can see, look, right here it crosses more than once, right here it crosses more than once, an infinite number of times it crosses more than once. So this is a no. Is this guy, this funny shape is called a parabola, by the way. You'll get more into that, but does this guy pass the vertical line test? Yes, because it does not cross more than one time. Same with our line over here. So you see that it's not crossing more than one time. So yes to both of these guys. They both pass the vertical line test. This line absolutely passes the vertical line test. It doesn't go more than one time. This square here would not pass the vertical line test because it passes more than once. So this is a yes. This guy is a no. So I think you might be catching on here. This one, also a no, because look, you can see right there, it crosses more than once. Same with like right there, right? All those different spots. So this is a no. Over here, this guy passes the vertical line test. Beautiful. So this one is a function. All right, so to sum this up, let's go back to that original page. Now, remember I said domain is your x, which is your input. So let's talk about that. In our this original example that I had, you see that we have our ordered pairs here. Remember, each one of these is an x and a y, x and a y, x and a y, x and a y. So for example, if you are asked for the domain for this group, right? The domain for this group, I would say, okay, my domain is, and you always put it in order and do not repeat it if it repeats. So we have -2, 3, 4, and -2. So you do -2, 3, and 4, and that would be my domain. Whoops, helps put a comma. Now, my range for this group is going to be my y. And again, you put it in order, but you don't repeat any that may repeat. So we say -6, -5, 1, and 7, because those are all of my y's there. For this table here, my domain are all of these, not is, they are all of these. So you see -4, -3, 3, and 7. So this guy back up here, this one, this is not a function because you can see that the domain repeated, or the x repeated, right? So this guy is not a function. This one here though, the x does not repeat. This one would be considered a function. My range is going to be -2, 1, and 6. Again, I only list it one time even if it does repeat. Now, I don't care if the range repeats. It's just the domain or the x that I'm worried about. Over here, I went ahead and listed all these out as an ordered pair, and you can see my domain would be all these x's, -2, 4, and 7. And because that -2 repeats, this is not a function. My range is going to be -3, -1, 0, and 4. Okay, now over here, I've got my, for my graphing example, right? I have my domain is going to be -2, then 1, then 4, but I see that that 4 repeats because I have both 4, -2 and 4, 6. So that, not a function. For my range, I have -2, -2, 2, and 6. Okay, so hopefully this helps you understand a little bit more about domain, range, functions, relations, all of those things and how they tie together. And I can't wait to explain linear functions to you because that's my favorite. We get started. We're getting right into the crux of algebra and it's going to be exciting. All right, guys, we'll see you next time.